Right. Thanks very much. It's good to be finally at RomHack. I've been asked a few times, hey, could you come? And it's like, sorry, not this year. I've other plans, unfortunately. So it's nice to actually finally make it here, also after a couple of years of desolation in the world. So when I was asked to do a keynote, I thought, okay, what can I talk about in an authoritative sense? And I thought, relationships. Like, I'm really good at relationships, apparently. So that's what I'm going to be talking about. You may notice a tinge of sarcasm there. But for people who don't know me, I'm James. I work in Google's Project Zero team, which is doing security research. And I specialize in finding vulnerabilities in Microsoft and Windows platforms. Now, I'm also sometimes a vendor. Like, I write code for the Chrome browser. I do a lot of work in the Windows sandboxing. So I write new code, I fix bugs. So I actually have to be a vendor sometimes as well. And probably why I'm here to do a keynote is I do have opinions, because it's always good to have opinions. So what is the relationship I'm actually going to be talking about? Obviously not between two people who love each other, but between researchers and vendors who don't necessarily love each other, right? Like, quick show of hands, who would consider themselves researchers in this audience? Oh, not that many. So is the rest of you vendors, or are you just uninterested parties, unaffiliated parties? I obviously picked the pictures to prove a point. Like, from a researcher's perspective, sometimes you always feel that the vendor is trying to put you down, trying to make your life difficult. But there is, of course, the sort of flip side of that. The researcher isn't always necessarily as generous to the vendor as they could be, as good-natured to the vendor as could be. So in an ideal world, we want this relationship to be better, because the end result of that researcher-vendor relationship is more secure products. Obviously, depending on why you're doing the research in the first place. Now, if you're wanting to construct a better relationship between researchers and vendors, at least from a vendor perspective, it kind of has to be something which you build in from the beginning. You don't design your products so that they are intentionally difficult to research. You don't set out to be like a terrible person towards these external researchers, because if you build any sort of product at any scale, there's almost a guarantee that some security researcher will come in and start poking holes in your software. And you need to be prepared for that. And the best time to be prepared for that is right at the beginning of time. So you're designing your new fancy product, right? And of course, engineering is going, hey, we can build this amazing system. Like, it's going to be the greatest thing ever. And then, of course, marketing goes, greatest thing ever, you say? Well, maybe we can do something with that. Now, if you actually want to build products which can stand up to the scrutiny of your average researcher, you really have to be basing it on engineering first. That engineering team has to be leading that product development, because ultimately, if they don't, like, if marketing is the cart before the horse, then marketing are going to dictate what you can and can't do in your product, what you can and can't do in your design, and then also big it up and say this is the best thing since sliced bread. And then a researcher is going to come along, rightly skeptical of those marketing person's claims, and say, hey, no, I think you're completely lying about that. And it doesn't necessarily give you a good impression, like, if your product is actually fairly weak. If it's just super hyped up, like, no one's going to be very happy about that. So, of course, if you're building your new fancy product, careful design is a must. Like, while there, of course, are vulnerabilities which can occur just from the implementation, ideally, your design should try and mitigate those before you've even started. Something, I say simple, but it's never simple, right? Like, don't box yourself into a corner where the only way you can write your software product or build your hardware product is using memory unsafe languages. Like, you might end up using C++ anyway, But if you can design it in such a way that you're not required to use C++, that you can use Go or Rust or some other managed language, then maybe that's a better design overall. And you will then have to deal with fewer researchers, hopefully, who are poking holes in your product. But of course, you also want to make sure that you don't have horrendous design bugs and design flaws in your product, especially for new existing products. Now, as a researcher, like, we're all time constrained. I know that. Some of them, I do this as a professional job, so I'm very lucky in that regard that I can just spend relative infinite time to do research. Not everyone can. But of course, if you want to have the maximum impact as a researcher and get on the vendor's good side, then finding bugs in their pre-release products is quite a useful way of doing that. Potentially, it's an interesting set of new code, new design code, new functionality, which isn't currently ready for prime time. And it's something you can get the ground floor on. You can get a jump ahead of potentially other researchers if you are looking at beta products. Now, in Microsoft's case, they have the insider preview, which you can just download and install. Obviously, give your email address to Microsoft to allow you to do that. But that's not completely terrible. Obviously, Apple have something very similar. And it just really would help in that sort of relationship regard to actually also not only look at the existing software, but also look at the new stuff which is coming out. But of course, back on the vendor side, it's useless if your researcher finds these amazing vulnerabilities in your product, but there's no way of telling them about it. Like, there's so many cases, like even in Project Zero with our supposedly cache, our name, it can be very difficult to find who is the point of contact in a vendor to actually submit security vulnerabilities to. Or even if you do, it kind of goes into a black hole somewhere and you get no feedback. And did they even receive it? Who knows? Obviously, a lot of these examples are from Microsoft because that is my specialty, of course. But Microsoft have a web page. Hey, go on here. You can click a link. It will take you to the vendor portal. You obviously need to create an account of some kind. And you can submit your vulnerability report, all the descriptions, upload your proof of concept, things like that. And it does a reasonable job. I have issues with the portal they've set up, the web portal, because it's your typical web application, which is just not fit for purpose in most cases. So usually I just email them, but at least you get a good response generally from the emailing as well. So again, if you're a vendor, you really need to have that mechanism to actually not make the researcher annoyed at you before you've even started to deal with the vulnerability reports. But it also helps that, especially for vendors which have large product bases and lots of technologies associated with that, especially legacy technologies, to actually define what's in scope. Obviously, that's going to depend on the vendor. Like in the Microsoft example, Microsoft have basically a criteria which says this meets the bar for releasing some sort of security patch out into the wild, because each security patch is potentially like 6 figures, 7 figures cost to Microsoft. So they want to kind of minimize the number of vulnerability reports that they actually fix as a patch. So Microsoft actually have this servicing criteria document on their website, which basically says, if you find a bug in this particular technology, we will just not fix it. And that can be a signal to you to just not do research in that area. Or if you do research in that area, it's not something that you you're not going to be annoyed if you can't get it fixed by Microsoft, because they've already told you they're not going to fix it. So a good example is if you can get from a normal user, normal unprivileged user to kernel mode, that is a boundary that Microsoft will support. However, if you are already an administrator, even though Microsoft have done loads of things to try and make running arbitrary kernel code more difficult, if you can find a bug which goes from admin to kernel, they do not consider that to be a security boundary. And so that keys you into, like, either you research that admin to kernel boundary just for the fun aspects of it, or you just don't do it at all and save yourself the time, the pain of actually doing that work. And that obviously comes down to the greatest incentive mankind's ever came up with. Cold, hard cash, right? Like, who doesn't like a bit of, like, a couple of €100 sent your way for finding vulnerabilities? But this has got to be done in the right way from a vendor perspective. Like, you can't just necessarily just like throw money like for everybody, because then like almost like there's no value to it at that point. But you want it as an incentive. Now, my view is that like when I started doing these kind of things, the best I was going to get, maybe a CVE, perhaps a t-shirt. If I was really lucky, I'd get invited to like an internal conference. But these days, it's very much, pretty much all vendors, there are exceptions, have some sort of monetary reward for finding vulnerabilities in their products, which feels like only right, because they're making potentially, especially the proprietary vendors, making a lot of money on their software, because it's kind of free money once they've developed it, right? And yet they won't pay you for finding bugs in their software. That seems a bit unfair. So they usually do this through bug bounties. And from a vendor perspective, one of the things you really want to be deciding on is what is it you want your bug bounty to be? Because that's going to, depend on what types of bugs you're going to receive, the volume of bugs you're going to receive, and also like whether that the return of investment of paying that money out to researchers is worth it. So on the one side, you've got bug quality. You're looking for bugs which advance the state of the art. Maybe they're demonstrating a new bug class. Maybe they're demonstrating a new exploit primitive. Maybe it's showing deficiencies in the current system, like where mitigations might be beneficial. That's sort of on the bug quality side. And the idea here is you're trying to incentivize people to send you bugs which help you to make better products and better determinations. Or you could just go for the route of literally, we're going to pay for anything which comes across our desk. And that's kind of the sort of opposite side to things. Like in some ways, you don't really care about the information gathering as such, although perhaps you can do some of that. But what you're really interested in is just fixing as many actual bugs as you can possibly find, and you just incentivize for that. And coming from the Microsoft perspective, they seem to have a bit of a schizophrenic view of this. Like they have some bug bounties which are nominally for information gathering, things like the mitigation bypass bounty. And they kind of almost imply that some of the general bug bounties that they do are also for information gathering. But then there was cases where they would just literally almost pay out for anything. Like a good case is related to file planting privilege escalation attacks. And they paid out like, it was a very weak spot in the security model of Windows. And like certainly some Chinese and Korean researchers basically automated the hell out of this. And we're making 6-7 figures out of Microsoft, out of bug bounties, just by submitting symlink bug after symlink bug to Microsoft. So they eventually said, no more, we're creating a mitigation. We've gathered enough information finally after receiving like hundreds of bugs. We'll now mitigate it. But they ended up saying that they're going to stop paying these bounties before they actually ship the mitigation. And that just riled up a number of people, because it's like, well, take your pick. Either you're information gathering, which is what you were doing before, or you're just paying for bugs. And they paid for so many bugs. Like after the first 5, which I submitted like 6-7 years ago, they had enough then to go, right, they should just mitigate this, right? But no, they kept paying and kept paying and kept paying until like they were out. I don't know what the actual figure was, but it was in the millions that they'd ended up paid out for these bugs. And that was a stupid thing on their behalf. And so all you ended up doing was annoying researchers, which doesn't help you necessarily, especially if you're Microsoft. Now, one of the things I spend the most time on, I would probably say, when I'm doing any research on proprietary software where I have no source code access, is just understanding how that code is supposed to work. Now, it would be amazing if every significant piece of code in a vendor's product, like in Microsoft, they ship a new product, especially one which is going to be heavily marketed. Like, if you're going to put something on your web page saying, this is the greatest thing ever, I also want you to provide me with documentation of what it's supposed to do, what its security boundaries are, what its basic functionality is, or a white paper of like actual like in-depth, like this is exactly what's going to happen with this software. So that not only do I understand how it works, I understand what constitutes a security vulnerability in this scenario. Unfortunately, Microsoft certainly generally do not do this. Now, some of that is almost certainly for commercial reasons, like they don't want to give away their secret source to other people. Some of it's just literally just bare tax cash, right? Like fundamentally, it costs money to write documentation because it's probably not, there might be some design documentation somewhere, but it's probably not in a form you can just disseminate to the average user. So it would have to go through review processes and all that sort of stuff. So it's a bit of a pipe dream, but I would really like it if like it was possible to get better documentation about on-platform technologies which a vendor supports. Now, if you're dealing with proprietary software and you're having to reverse engineer the binaries themselves, stick it in, say, IDA or Ghidra, if you just get, say, a 100 meg blob, like you're trying to reverse engineer iOS and you just get like a 100 meg library cache file, whatever, with no symbols, very little information from that, then it's a massive barrier of entry, right? Like what you want as a vendor is to incentivize as many researchers as to come along to help you find vulnerabilities because they won't pay like the actual people in their own company to do this all the time. So they need external help as well, right? And if you just give them a 100 meg blob of executable code, it's going to be very difficult to determine what that or does not do. So this is where symbols can come in handy. Microsoft have historically released public symbols for all the sort of core OS components. So I can load a binary up in IDA, get the public symbols, which are usually just like function names and things like that, but you can obviously infer a significant amount about a application based on just the function names themselves. One big blind spot in Microsoft's case was Office, who had never released public symbols as far as I'm aware, not intentionally anyway. But last month, they finally announced that, hey, we're going to actually start releasing public symbols for Office. And it might actually incentivize me now to look at Office because the barrier of entry to look for vulnerabilities in the Office suite is now potentially lower. So as a vendor, it helps to actually release this sort of information. And then finally, after all this, you found your amazing vulnerability. Like, it's so awesome. Like, it's going to change the world. And of course, you want to get your payments, right? But when you submit your vulnerability to Microsoft or the other vendors, just don't be a dick about it, right? Like, don't sort of like demand it like I'm the greatest thing ever, because unfortunately, like, very few people are the greatest thing ever. Vendors don't necessarily have to listen to you. And if your ultimate goal is to get more money out of that vendor based on your knowledge and your ability to find interesting vulnerabilities, then being a dick to them isn't necessarily going to help you in that regard, because it may preclude you from getting useful information out of them. So they may tip you off about, hey, there's some interesting functionality here, maybe you should have a look. Or even like, we want to contract you, you're so good at finding bugs in this area, can we give you money as a contract to actually find vulnerabilities for us in just a contract relationship? And that's obviously going to be precluded if you make the vendor's life difficult, right? So that's sort of my summary of where the sort of vendor and researcher could maybe make our relationships better. I thought it's worth going through just a quick sort of case study, I suppose, of an area of Windows that I was researching into recently. And this is Windows Credential Guard. And Windows Credential Guard is a technology which was introduced in multiple versions of Windows back in Windows 10. And what it uses is it uses Hyper-V to create special isolated processes. And one of the key weaknesses, and if you ever do like red teaming or penetration testing on Windows domain networks, like almost certainly you've run Mimikatz on a box, and pulled out passwords, pulled out encryption keys for Kerberos, and then used that for lateral movement and attacking the network. And the problem is, like, that information, that secret information, is just sitting in a process that any user, well, any admin user can access. And yes, you can have detections and other sort of stuff, but it's not ideal. So the idea of Credential Guard is we're going to create a completely isolated environment, and any key material, like it might start obviously over here, but it's used only as long as it needs to be, and it's encrypted into some form inside this virtualization container, and the container is the only thing which can decrypt this secret information. So it exposes an API, which you can say, okay, generate me a Kerberos request, and it will use its encrypted key, decrypt it inside virtual secure mode, and then return you the encrypted blob you can then send off to the KDC or whatever it happens to be. So this is kind of a neat use case. So obviously it's probably been designed, right? But this blog post from a couple of days ago by Dave Weston, who's the VP of Enterprise and OS Security, was basically how Windows 11 is the greatest thing ever for security, especially in hybrid work. Hybrid work, because everyone wants the hybrid work. And it specifically points out Credential Guard, saying we're now enabling this feature by default on Windows Enterprise because it's so amazing, right? And of course, if you read this, it is pure marketing bullshit, right? Like, it's all marketing. My general red flag is if any technology in Windows has Windows Defender as the moniker, it's marketing as opposed to anything else. And yes, this is almost certainly designed and engineered, right? But the marketing kind of oversells it, I feel, in some ways. Like, is this really true? Is this as amazing as they say, right? Well, one thing it's not as amazing as they say is in the bug bounties. So Microsoft's bug bounties have a number of higher value targets which they consider to be high priority. Like, potentially you can get $250,000 for finding a critical RC in Hyper-V. But if you actually go through this list, there is nothing in here which is specific to Credential Guard. You may think it's like Hyper-V. The Hyper-V bug bounty will cover that, but it doesn't. Hyper-V 1 is all about sort of RCE, remote information disclosure, remote denial of service issues. Not can you get into virtual secure mode and steal keys. As we'll see, about the only thing which it can be covered under is the insider preview one, which just pays for bugs inside insider previews, those sort of beta versions of Windows. So it's obviously not important enough that they're explicitly going to say, hey, it would be amazing if you could find bugs in this software. Is the documentation? Not really. You can find pages on MSDN or Microsoft's website which says how you turn it on, and a very brief overview of the functionality of it, which makes claims which actually, when I then looked at it, turned out to not be entirely true. The only documentation which is remotely relevant is there's something called Remote Credential Guard, which, as the name implies, is Credential Guard, but remote. And it's used for like RDP and securing RDP authentication. And it turns out that what they basically did was they took the Credential Guard interface that they'd already designed and basically just remoted it in some fashion. So a number of these calls were basically the same as if you looked at the Credential Guard interface. And so you could just extract sort of like the basic information structures and stuff like that. It turns out like there was actually documentation error in this. One of the documented commands had like a magic value. It said you must set it to this value. If you actually set it to this value, you got memory corruption in the virtualized container, because this magic value was like literally a magic value, and it changed between releases, and so it did something bad, which is kind of funny. Now, at least they've got symbols. Yes, just public symbols, but a lot of this code is written in C++. You get the mangled symbols, so you get like at least type names for free. You don't get full type information, but that's not too bad. So from my perspective, was it a success? Well, I found a few bugs, like 9 actual bugs in Credential Guard itself, in the Credential Guard interface, and 2 which were adjacent related bugs to Windows Credential Guard. And these were pretty serious. These ranged from like full-on like arbitrary code execution inside the virtualized container, which doesn't sound great, to effectively encryption oracles or decryption oracles, where you could decrypt key material and things like that. Like, these don't sound like a well-designed system or a well-implemented system, which you need to have such a big marketing push around. So I thought I'd find, because obviously this is a keynote, it's supposed to be boring, it's supposed to be dry and non-technical, but I thought I'd at least like put in a few slides of technical stuff at the end. So this is my favorite bug, in my opinion, from the vulnerabilities that I found. And it's basically a decryption oracle. And it's kind of fundamentally a design problem, like a misunderstanding of kind of how like they should have been deploying this functionality, right? So it was a function which I found on the RPC interface, which you could call from user mode into the secure mode, NTLM, IUM, which is isolated user mode, calculate NT response. And it takes 3 parameters, takes a challenge array, it takes some sort of encrypted credential, and it returns you this NT response. And it internally, it decrypts it, which is correct. It has to decrypt this buffer inside the virtual secure mode, because it can't use it otherwise, and then calculates the NT response. RTL calculate NT response is better known to everybody as system function 009. I love that function, it's amazing. But what that is doing is it's generating an NTLM v1 response hash. And if anybody knows anything about NTLM v1 response hashes, that's bad. So because it's basically using the key, like a hash key, to generate like 3 DES blocks. And it uses single function DES, and it's basically, especially if you control the challenge, trivial to brute force. Like, trivial, I say, like, relatively speaking, like you can use rainbow tables and stuff like that to brute force this back. So you can take an NTLM v1 response hash and basically decrypt that credential buffer. So you can get back. And in fact, what you actually get back is the original NT hash, which is the MD4 sum of the user's password, which is all you need to basically compromise NTLM. So that sounds bad, right? But NTLM, whatever, right? Like, that's not necessarily that interesting. NTLM can be disabled on enterprise environments. So it'd be really useful if we could attack Kerberos instead, right? So it turns out that I found that, say you have a RT4 key for Kerberos. Kerberos can have multiple different key types. You can have RT4, you can have AES. There's a function which will take an encrypted RT4 Kerberos key and create what is called a supplemental credential. And the supplemental credential is a way in which if you just authenticate using Kerberos, allows you to still use NTLM because it gives you the correct hash value. That obviously returns back to user mode an encrypted supplemental credential. So again, it's not something you can directly use, but you can pass that function, that credential, to another function. This NTLM make one-way function string from isolated user mode supplemental credential. Breathe. And that gives you now an encrypted one-way function string. Okay, what can we do with that? Well, we can pass that to calculate NT response, which you've just seen, and we get back our NTLM hash. We throw that in our cracker, and we've just recovered our RT4 Kerberos key. Fantastic. We can now apply this to Kerberos authentication. But so what? The RT4 encryption key is by design the same as the NTLM hash. We've just done all this for nothing, right? Especially when you get things like protected user groups involved. Like protected user groups was something added in Server 2012, which basically prevents a user, like you can add it to, say, domain admins, which prevent them using NTLM and prevents them using DES or RC4 encryption types in Kerberos. So is all this worthless, right? Like, assuming that the system is well designed and secure, is this completely pointless? Well, it turns out that that initial function had a bug. And specifically, each key has, of course, the key data itself, the size of that key material, and the key type that is associated with that key. And the only thing this function checked was the size of the key, not the key type. And it turns out that there is an existing key type in Kerberos, which happens to also be 16 bytes inside as the RT4 key. That's the AES 128 key. And this, of course, is secure because it's AES, right? So instead, what we can do is we can, instead of passing an RC4 key in, we pass an AES key. And from the algorithm's perspective, it doesn't matter. It doesn't realize that this string of 16 bytes is actually generated from an MD4 sum of the password versus it's just an AES key. It can't tell. There's no way of determining that. So the end result of that is, of course, you can apply this and decrypt arbitrary AES 128 keys from a Kerberos user. So even if they've got a protected user group, you can steal it doesn't disable NTLM in these functions, right? And that's kind of like, why is that function even there? Like, that seems a pretty terrible thing to add into your design. And this is a screenshot I took of crack.sh. Just run that, stick it against their rainbow tables. And in this time, it took 45 seconds. And that's probably like just mainly waiting, right? So it's pretty practical cracking time for your AES 128 key. And once you've got that, you can arbitrarily request TGTs, use Kerberos across the network. You've compromised that user. But because that bug bounty didn't have a specific category, then you're left with the insider preview bug bounty payments, right? I found 9 pretty serious bugs in their super highly marketed feature that they've added to their product. And maybe, fortunately, I didn't have to do this because I get paid to do this on a regular basis. I could maybe have got 20 grand out of it for a month of work. That might be a reasonable payback for that. But that seems pretty poor for something which is apparently so important, right? Okay, so in conclusion, like, do I ever think that the researcher vendor can actually love each other and hug and be really, really happy together? Probably not. Like, I feel there's always going to be antagonism between vendors and researchers just because of the nature of the relationship. But I think both vendors and researchers can do a little bit towards reproaching each other, and maybe they can have a cuddle once in a while, right? So thanks for listening to my keynote, and that is it. Thank you very much.